Okay, let's talk about the history of programming paradigms. If you are using today C++, Java, Python, or any other programming language, this programming language was not made for the first time as it is. In fact, there were some other programming languages in the market, but they were having some issues, some drawbacks, some flaws, and people stopped using them because of those drawbacks and issues, and new languages came to the market to address those drawbacks. If we go back to 1940, where the programmer had to write a software system in the form of ones and zeros, and there was a programming language called machine learning. It was first generation language, but that language has the main problem, it was quite difficult to understand, and it was prone to errors, and it was also complex. So then later on in 1950 and 1957, procedural languages came to the market like C, FORTRAN, Pascal. But these languages had also some issues, some limitation, like data was scattered across the program, and there was tight coupling between components, and a small change could cause big problems in those languages. Program worked well, but they didn't as well. Then later on, the idea of object-oriented came from the introduction of Simula and Smalltalk. Simula introduced classes and objects for simulation, while Smalltalk took the idea further. Everything was an object. These languages showed that software could be designed to mirror the real world. For the first time, software had structure that made sense to humans. But there were some issues in these languages, like there was poor performance, steep learning curve, limited industry support. They were powerful in theory but difficult in practice. The idea was right, but the technology wasn't ready yet. Then the mainstream OOP languages came to the market. C++ brought object-oriented programming to existing C developers, while Java simplified object-oriented programming and made it safer. These languages improved the code organization, supported large-scale systems, encouraged reuse and maintainability, and object-oriented programming moved from labs to industry. Then improvements in safety and maintainability and portability was introduced by Java, by automatic memory management, stronger encapsulation, platform independence. So these addressed many of C++ weaknesses. We traded a little performance for a lot of reliability. Modern languages like C#, Python, and Ruby reduce boilerplate, improve developer productivity, combine object-oriented programming with functional ideas. We stopped chasing purity and started chasing productivity. Object-oriented programming is an implementation of object-oriented modeling. We will talk about the object-oriented modeling later on in the coming lecture, like what is object-oriented modeling and how we implement object-oriented modeling using object-oriented programming language.